Let's take a look at how we can build the interest rate term structure from the Vassilchak model here for the instantaneous short rate. Okay, now if we have the Vassilchak model written out this way, and from the fundamental pricing PDE, that we can, substitute the price of derivative asset to this price of the zero coupon bond. So essentially, what we have here is another way what we have written out for the PDE on page 7 of the slides. So if we look at that, so if F is any financial asset, and given the interest rate follows this process, F must follow this process by Ito's lemma, and you will have this fundamental PDE here for any interest rate derivatives. So therefore, that apply. If F is any asset, then it can be a zero coupon bond. So you can put in a P price here for this F and substitute in the Vassilchak process for this interest rate. Now you will get this particular PDE here. Now we know that this particular PDE has a generic solution, has a form. That generic solution will take this particular form here, with an A as a function of little t and big T, and a B also a function of big T, little t and big T here. But we don't know the actual functional form for A and B. This is what we're gonna find out next. So although we don't know the actual functional form, we can take the partial derivatives. So if you take dp dt, you have this, and dp dr, you have this, and the second partial with regard to r, you have this thing here. Note that this b little t here is db dt, so this is actually a partial derivative here. So is this a, which is dA dt here. Okay, so we have basically obtained those three terms: this, and that. So we can plug in those expressions back to the PDE if we know that the form of the solution will take this form. Okay, so once we have done that, we basically have this here. Okay, so and this must be satisfied because this really is the original PDE. Now we can rearrange a little bit. First of all, we take out the factor e to the power of minus br, and so because this thing is equal to 0, that means whatever in the bracket must equal to 0. Then further, what we can do is we can take out a factor of RA. So you have RA, and this one here becomes 1, and this is where we get the A and B, and this BT is from here. Okay, so we have terms that are related to RA and the terms that are not related to RA. So by writing it this way, we know that this part must be 0 and this part must be 0. So we now have two simpler PDE that we can solve to determine the actual forms of A and B. Now to solve those two simpler partial differential equation, we also need a boundary condition. The boundary condition is really when the zero coupon bond matures. So the P, big T, and big T, when it matures, must have a value of 1. So the maturity value of zero coupon bond having a value of 1 implies A must be 1 and B must be 0 at maturity. Why? If you look back, if this is 1 at maturity, meaning when little t becomes big T, this is 1, then this B must be 0. Okay, so that this e to the power of this must be 1. And so A must also be 1. So A big T and big T must be 1, and B big T must be 0 in order for this to become 1 at maturity. So you know this boundary condition, and you have two partial differential equations, solve them. You will then have a functional form for A and B, and therefore we know the exact functional form for P. Okay, now once we know that, we use this earlier condition here, we will be able to derive the expression for the interest rate term structure R little t big T for any big T here. Okay, so essentially that will become this form. So therefore, if we were to know the process followed by the instantaneous rate R, in this case, it follows the Vassilchak process, and then the interest rate term structure must have this particular form, or the zero coupon bonds under that world must have this particular form. And you look at the term structure of interest rate under Vassilchak, they actually have pretty good shapes. So have flexibility. So this is basically the an uprising term structure of interest rate, which is something we typically observe. We also, so this shape is also allowed. So sometimes we have inverted curves. So the Vassilchak allows that as well. And the Vassilchak also allows some, shape like this, which is you go up first and then you go down later. So the Vassilchak does provide certain flexibility in generating the shapes of the term structure of interest rate, which we commonly observe in the market.